In problem 36, we're going to work with an application of function operations, and that's a classic application involving profit, revenue, and cost. So we have a local courier service estimates its monthly operating cost to be $1,500 plus 85 cents per delivery. The revenues are $6 for each delivery. Let X be the number of deliveries in a given month. So part A, we want to write our cost function. So the values here, 1,500 plus 0.85, those are the values associated with cost. So we're going to write our cost function as our base cost, which is $1,500 plus 0.85 times each delivery, so 0.85x. Our revenue, we're told $6 for each delivery is how much we make. So revenue is 6x. Profit is revenue minus cost. That's given to us in the table at the top of the page. P of x equals R of x minus C of x. So let's figure out what our profit function is. We're going to take our revenue function, which is 6x, and we're going to subtract our cost function. Be very careful. You must use parentheses here so that the signs of your profit function are correct. So here is my cost function, 6x minus 1,500 plus 0.85x. If I clear the parentheses, there's a penalty because of the negative in front. So it's negative 1,500 minus 0.85x. My profit function then, P of x equals 6x minus 0.85x, which is 5.15x minus 1,500. So there is my profit function. Part D says determine algebraically the break-even point for P of x and how many deliveries you must make each month to begin making money. So break-even point will occur when P of x equals 0. When profit equals 0, right after that we start making money. So I'm going to take my 5.15x minus 1,500, that's my profit function. I'm going to set that equal to 0, and I'm going to solve for x. My first step is to add 1,500 to both sides. So 5.15x equals 1,500. My second step is to divide both sides by 5.15. If I do that on my calculator, I get x is approximately equal to 291.26. So we must make 292 deliveries. Notice we round it up to the whole delivery. So we must make 292 deliveries to start making money. Let's confirm this using a graphical method. So if you look over here on the graphing calculator, if we go to y equals, first we're going to enter our profit function. So 5.15x minus 1,500. Then let's go ahead and enter the 0 function, because we want to see where those intersect. Now, we're going to need to work with our window here. And my x values have to be at least 0, because I'm not going to make negative deliveries. I figure I'm going to have to make quite a few deliveries each month, so I'm going to let x max be 500. For my y min, if I look at my profit function, I see that the vertical intercept is negative 1,500. So I want to be able to see that on the graph. So I'm going to start actually at negative 1,600. And then I want to give myself enough room to see a larger profit view. So I'm going to let my Y max go up to 1,000. Now I'm going to go ahead and press graph so that I can make sure that I have a good view. So there's my profit function. What I want to know is what's the X value right here, and if it matches the algebra that was done in part D, it should be about 292. So I'm going to use my intersection process. So second, calc, number 5 is intersect, and then I'm going to press enter 3 times to navigate to the intersection. I see that I have 291.26, which is the same thing that was found algebraically. I'm just going to record this information here graphically and finish up this problem. So we can see graphically that we confirm the result that we found algebraically. So we must make about 292 deliveries to start making money.